Hello students, welcome back. We went through most of the important limit computations. Trivial limits, of course, that's not very important. Just plug in and if it works, it works. If it doesn't, it doesn't. 0 over 0 type limits, okay, those are important. Infinity over infinity type limits, equally as important. Which is easier? 0 over 0 types are easier in my opinion. Usually you can factor the numerator and denominator and work out. If you have some square root expression, think about the conjugate. Infinity over infinity type limits, take the highest degree terms. How do you calculate the highest degree terms when you have radical? Well, think about fourth power inside the square root, so second power. Or sometimes you may have a sixth power inside the cubing root, so second power, things like those. So consider the radicals or powers inside of radicals. And then my suggestion is to plot. Plot and check out the horizontal asymptotes. Sometimes you may get a nasty surprise, like you did over here. Further limit problems, how about some one-sided limit problems like these? If you just plug in x equal to 3 and you have non-zero over 0, so undefined, you can walk away. But 3 minus, in that case you have to specify whether that's positive infinity or negative infinity. You cannot just walk away. How do you get that? Well, in my opinion, the best way is to plot. Around x equal to 3, we have this vertical asymptote, and then 3 minus, so left-hand side limit, it's going down, so you can easily conclude that this is negative infinity from the graph. In my opinion, this is easiest. If you are not allowed to use calculator, in that case, you may have to do it hard way, factor, and then do some sign analysis. Plug in 3, then that's positive. No problem there. If you plug in 3, 3 plus 3 is positive. Now 3 minus 3, that's normally 0, so you have to consider whether it's 3 plus or 3 minus. 3 minus, a little bit less than 3, so that's negative. So overall, we get negative infinity. If you have 3 plus, then this is positive, so you get positive infinity. But this is when you have a special exam, the calculators are not allowed. Most of the time you'll be able to plot and figure those out. The same here, you can plot. Do I have a plot? Yeah, okay, I have a plot here. Oh no, this is not a plot. That's not a plot. E to the tangent x is going from 0 to pi over 2. Okay, so looks like it is going to pi over 2 plus, sorry about that, pi over 2 to someplace else. Okay, alright. So pi over 2, starting from 0. You can see that from the curve. Or 0 to pi, okay. From the left, it blows up to positive infinity. And then from here, start from 0 to like that. Okay, I have a good reason. I didn't provide you with this graph because this graph is hard to see. Better yet, use the behavior of the tangent function and exponential function separately. And tangents goes to negative infinity if I approach to pi over 2 from positive side, so e to the negative infinity, going down to 0. So here, going down to negative infinity, and then e to the negative infinity is this way. How about this? Again, you can plot 1 over x minus 1 over, I don't know whether absolute value sign is supported by, it does not. So you have to know some mathematical code, I guess. So when x is going to 0 from minus side, going to negative infinity, going to plus side is going to 0. As a matter of fact, absolute value of x is negative x when x is a little bit less than 0. So we end up with 2 over x, so that's going to negative infinity. When x is 0 plus, then absolute value of x is same as just x, so 1 over x minus 1 over x, so we get 0. Another problem that you may have to rely on calculator, the grapher. Calculator and graph plotting are two different things, even though you can sometimes use calculator to plot. So if you plot, let's see, what do you have? Tangent of x over 2 over x squared plus 1, and that's approaching to pi from plus side. Looks like it's going to negative infinity like this. Yeah, that's negative infinity. So plot, and most of the time you can handle those. Again, I have to say these are just peripheral topics. Infinity minus infinity type limits. Well, if this had been some math course for math majors only or something like that, then I would emphasize this to a certain degree, but not here. It's not like this is a peripheral topic or something like that, but because this can be a bit too complicated. That's why. First example here, you can combine two fractions, and then you can turn it into 0 over 0 type or infinity over infinity type limit. So if you take the common denominator and then work out, you end up with what? You end up with a 0 over 0 type limit. So factor and simplify, you have your computation. That wasn't too bad. This one will turn out to be bad. So we have infinity minus infinity type limit. And just like the previous example, I want to change it into a fraction form. How do I do that? Well, we have square roots, so think about conjugates. Multiply the conjugate of both numerator and denominator, change this minus to positive, and then do your simplification. Fold out carefully, then the square roots will all disappear, and you're going to get this one squared minus that one squared. So square root will disappear. And then the simplification yields just negative x, and down here, no more 0 in denominator. So basically, this is just typical infinity over infinity type limit, and simplification yields negative 1/2. You can always check. Check it with plotter. Plot the graph, and you'll see. Well, all right, that completes the limit computation. That's it.